How's it going, everyone? Welcome. Javier Gonzalez here. Today we're going to discuss about what monas is, as well as further investigate what is this asynchronicity with reactive data. But first, uh, recap about this monad and how do we get here as a way to understand and then embrace the complexity. So, because this particular course is all about is understanding how we're going to use now the concurrency in our programs when we are writing these asynchronous applications, or when we're going to write our asynchronous programs to handle this concurrency in our applications. So it's important to understand that where all of this come from, okay, from a conceptual and practical approach. So because of that, so parallel and async is one of the terms that we need to understand. What is the subtle difference with in terms of humans and computers? So humans are not. So when we think that when we think we are multitasking, we are not. True multitasking from the computer sense is that you're going to pass several tasks to multiple threads that is going to be executed at the same time. From the biological perspective, as a human, there's a lot of things that need to happen behind the scenes, and that is true parallelism. But cognitively speaking, this is not true. So the way how do we handle and perceive and act upon things is mainly based on things that overlaps at a time, tasks that overlaps at a time. So, which is if you're cooking some meal, right, and then suddenly your mom calls, now you can think that you are parallel, but what you're doing is just putting your attention in the kitchen, the oven, all right, and also listen to your mom while you're cooking, right? But then you swap your attention to your mom, all right? Stop cooking, whatever what you're doing, reply her back, and switch the task. So the idea here is that by understanding now how can we write our code, how our brains plan things when it comes to creating application or writing this particular set of instruction to the machines, a lot of the time we will going to get now a much more better understanding of ourselves, that what our application are doing, and it's important to understand now what are the tactics and the patterns and the fundamentals that we need to use, especially if we want to be a competent JavaScript developer. Because we have to be strategic and tactical about how we're going to handle this concurrency and implement the asynchronicity in our programs, right? So the way how can we handle that or describe that is tools that are provided by the platform, in this case browser, like to JavaScript, for example, like timers. And then here, the way how we handle this is through using callbacks. So because now JavaScript is a single thread language, it means that it's going to evaluate one line after the another, unlike other programming languages that they can now handle all of this chunk of threads in parallel. One of the great things of JavaScript is that it resembles a lot of how we as humans now plan and act on things. So writing synchronous application is something that makes a lot of sense, but when we need to write this asynchronous programming to handle this concurrency, we have now tools that are not designed for us, right? So for example, like callbacks, where the idea here is that you're gonna pass this set of instructions to continue the program execution at some point in the future. Now, understand that with callbacks, there is some trade-off that we have and one of them is the inversion control, because we're passing is a set of instructions. We don't know when those instructions will be executed. I mean, we know when those instructions will be executed, but we don't have guarantee that they're not gonna fire too many times or too few times. Not too fast, not too slow. Don't lose data context, or don't swapping errors, because all of this is delegated to whoever is going to handle that. And the other is that they're not reasoned about, because this is not how our mind works. This is not how JavaScript works. Okay, so there is a lot of people that say, hey, but you need to understand how the JavaScript engine works for now. That's right. However, we also look at how when we need to handle this asynchronicity, which is performing multiple tasks in parallel. Let's say you want to call to, let's say you're implementing a checkout from your e-commerce, and then you want to now trigger that to the payment processor, and then after that you want to, once that is done, store that in your database and then send to your own marketing or analytics servers. Okay, and when you're doing this kind of operations, whether it's in parallel or sequential, we need to find a way of how can we do that. And we can do that using closure in JavaScript. And by the time that each one of those problems has been resolved, well, we can now then show them in the proper order. It sounds very easy to say. We also look at how can we actually do that, and how hacky that things feels about. And not only that, there are some patterns to actually handle that in a much more convenient way. This is some patterns that way predate JavaScript, like thongs. And now thongs say, hey, I'm gonna be a wrapper around a function that has everything that it needs. So by the time you call me, you're gonna get is that value. This is now a synchronous thong, right? And this is huge, because it's like you're putting in a container everything that this function needs, and by the time you call it, you're getting that back. So this is pretty much like you say, I have this list of things that I want to buy at my supermarket, right? This is my grocery list. And then I want to, and any time that I go to the supermarket, I'm gonna get that things as expected, right? I don't care how long it will take. All right. I just wanna make sure that I'm gonna get what I need in this list. So again, what it's doing here is to actually, from thongs and in the asynchronous perspective, you say, hey, this is a function that have everything that it needs, except we're gonna pass a callback. So by the time that a computation has been processed, or by the time now that processing has been done after an X amount of time, after we wait for that data to come back, then we can get that in our callbacks. So thongs, the problem that the thongs solve is this time concern around a value, which is a great thing. In fact, this is huge, because dealing with time is something that is not trivial, especially in programming. However, we still have the issue of that they are not this inversion control, because after all, we are passing this callback, and then we are assuming that whoever is creating that thong, that wrapper, actually work as expected. But it solves the problem of this reason about. So now we can have all of this thongs or nested thong, so we can use that. and this is also something behind the scenes using is how can we use now thunks with closures as a way to now coordinate is the response and the order of how things are going to be shown. That's pretty powerful. That's also mind-bending. In any case, and how closures allow us to actually do this kind of thing. So, so closure, after all, the next step of thunks is now how can we deal is with this inversion control. Okay, we're passing a callback to something, but we expect that to now. So all of these trust issues that are generated by passing something to someone else. So for example, hey, I don't want this function to run too many times, too few times, too early, too slow, that kind of thing. Now with promise, which is a concept that comes from the programming language called E. Mark Miller, which is one of the TC member, one of the members of the TC39 commit, actually made that language, and in that language you have something called like future. In JavaScript we have something close to that, according to Carl Simpson, but this is with Kyle Simpson. Or with promise is that we need here a placeholders to eliminate time concerned around wrapping a value. And not only a placeholders, it's a guarantee that by the time that that data is done, we're gonna get that value. Okay. So now, instead of actually passing a callback, you're actually going to pass a callback. But instead of actually passing a callback, now promise is an event listener. So you can think of your promise as an event listener of future data or a callback manager, right? Where it has now this particular structure of how now you are going to handle is or when you're going to subscribe now to callbacks, when you're going to subscribe to unfulfill and unreject, right? So it means that by the time you now get that data, so this placeholder, this promise now resolves that. So by the time now that's promise settle the result on success, you're going to now subscribe to a particular event listener, which is .dead. And then you're going to extract the value and perform your and define all of this instruction in your program. And the other is on reject, right? So now you're going to subscribe, which is the .catch. You're going to subscribe to this to actually handle that particular error. This is huge because this now using a silly example, for example, when I walk up to the counter of my favorite restaurant, pizza restaurant, and then I asked the lady, hey, I like a chili pizza. She say, well, that'll be $10.49. I hand over the money. And what I'm expecting to get is a chili pizza, but what instead I'm given? Well, a receipt. Well, an important thing, with more importantly, a number on it. Order 326. Okay, so this order, this recipe now becomes an IOU, a promise between this transaction that I begin. So this doesn't stop me from actually thinking about that. In this case, like thinking about is how how wonderful that pizza wood is, and all of this slicing pizza dancing around me. Uh, yeah, yeah, because I mean, I mean, I'm starving. I'm famished, right? I can't wait. I can't wait to eat. So, uh, this placeholder, this receipt, now becomes this IOU, and when they announce those magic numbers, order 325, then I walk back to the counter, receipt in hands, I hand over the receipt, and what I'm getting instead is the value. So the thing here with these placeholders, which is something that is interesting in the context of bonds or stock options and all that kind of thing, they are just promise of future value, of future remunerations, which is something interesting. So these promises, like, it can be applied also to the context of the finance. When you have now this particularly bonds or stock options that are issued, or all of this debt that are issued by companies, organizations, or governments, right, as a promise that we're gonna we're gonna sell this, you're going to get this amount of money at some point in the future, okay? But this is the promise that they put in here. But unlike humans, organizations and structures, now computers, they will guarantee you that. So this trust issue that was generated in human organizations, now computers say, no, take it. And this is now generating this trust that is needed. Again, when we want to do this kind of transaction. And I think that this is crucial and critical, especially when we are going to handle this transaction. Is that, hey, this is a receipt that I'm gonna get. This is an IOU, okay? This is a promise that I'm gonna get the thing that I need to, and you're gonna fulfill that. So this is quite powerful and quite interesting here in this. Again, when writing this kind of application, when writing now applications that allows to interact with different people, right? If you're building an e-commerce, it's like, that's awesome. Of course, you have now a server that is centralizing everything that happened here. And then you want to provide that service to all of these different people to actually buy and sell stuff, with the promise that you're gonna get what you're gonna get, right? In theory. So, for example, applications or companies like Amazon, eBay, Craigslist, which has become like the niche for some illegal activities, activities that are not regulated. I will say that activities that are not regulated, and yeah, it's like, okay, man. All right, but again, the point of this is that this promise actually is now providing is this trust that we lost when we delegate stuff, when we pass a callback to something. All right. So this is interesting because now we also look at how can we handle this flow control in our promise by using the .then, okay, and also starting to think or to look at some of the common. Let me see if I can get this exactly. For example, here, and some of the now common concept of functional programming. Look at this, because at the end of the day, these promises, okay, when you want to actually is starting to now change multiple of these transformations or flow control, you want to define all of these statements. We're starting to see things like this. So, for example, this is known as the dot 3 point 3 point. Let me see this. I mean, point 3. All right. So point 3, where point 3 is define the relationship between the input and the output. It's like, hey, instead of actually passing the arguments to this, if they have the same shape, the same input and the same output, now I'm going to actually is define this as it is. This might be quite confusing for someone that is not familiar with functional programming because you expect to pass now arguments to this. But again, what we're doing is this. So what we're saying is that, hey, this get file, which is something that is not here, if you take a look now at this. So this get file, which must follow is the shape of the input as well as the output. So the shape of this function is that, hey, do you follow is the shape of this input that map need? And in this case is that you're gonna get the first value as expected. And also you have now other values as well, right? But is the first, is the input, or is this a function shape, if the function shape now match the function that is expected to pass to the callback, so now things started to actually work as expected. Wait, what? So, in other words, it's like what you're doing here is to say, hey, I'm passing this function that is going to take all of this input that the map can handle, and then the first parameter is this value, and then the second parameter is the index, and the third is the current array, okay, or the original array. And in this case, we're getting is all of this value. We're going to now create these promises here. Okay, and by the time those promises has been resolved, we're going to now is call that. So by using is this fake Ajax, which is actually passing down this callback, so we to mimic that. All right, this is when it's going to now handle this asynchronicity or mimic this asynchronicity here, and because we're passing now the result, which is say, hey, by the time that now that is done here, okay, I want you to now is call that with the proper arguments that it needs to, right? So if you're not quite familiar with this, doesn't matter. It's a matter of time to get used to that. But after you do that, right, you're gonna have now an array of the promise, which is this what you create here. Okay, map what it does is to apply a transformation on a particular data structure, and in this case, and most of the time we do that to arrays. All right, we can also apply transformation to hash. Or to binary tree, all right? Something that we're gonna explore that later. And this does say, hey, I'm going to now compose all of this into one promise, which is I'm going to execute at the end of the day. So that's what we started to hear with a promise resolve. And then started to change all of this or compose all of this flow control in our promise. Again, this is just a very specific way of handle these promises, all right? And that's where we have now abstractions much more useful, like the promise.all and promise.all settle, race and any, where now promise.all say, hey, resolve resolve all of the promise or because the thing here is that it's like okay So promise.all says, for promise.all says, okay, so promise.all say fulfilled on all the, exactly, fulfills when all the promise has been success, all right? Okay, so fulfill, okay, fulfill when all of the promise has been fulfilled, or when any of them, or reject, which is this. So fulfill when all this promise has been fulfilled, or reject when any is rejected. Whereas with all settle, say, hey, fulfill all the promise, settle, whether it is fulfilled or rejected. So you're going to actually have, when you perform that, which promise has been resolved and rejected, right? So like any, it say, hey, fulfill when one of the promise is fulfilled, and reject when all of them are rejected. And the same for the race. Is that, hey, fulfill with the first promise that was resolved or that was fulfilled. But all of these are just abstractions of the most common thing that you're going to do when you're handling your concurrency, right? Hey, I want you to now fulfill all of this promise, and if any of them is rejected, reject that, right? Again, it doesn't solve the rollback operation. Okay, it's only solved is the concurrency, the coordination that happens or that it needs to happen when you are waiting for all of this tasks to be complete at some point in the future. This concurrency stuff. But that's interesting. That's very interesting because now promise, after all, is a monad. You may wonder what in the F is a monad, right? So a monad is a monoid in the category of end of functors. Okay, there's a lot of jargon here. So for example, like what monoid and the end of functors. But a more friendly approach to this, because this is part of the functional programmers, okay? But a more friendly approach is a pattern for pairing data and a set of predictable behaviors that let you interact with other data and other data and behaviors, or pairing, right? So it's a data structure here. It's a functional data structure, right? So monads is a way of how you can model state change of a value. Perhaps this actually doesn't tell you that much, but because you can understand monad, at least for one of these examples, which is monads are a way of how we model state change of a value. Since it is a functional data structure, in other words, it's like a drawer or a container that we can store things and store data and apply transformation of that data, and the output is a new data structure, is a new monad with this new value applied. So again, in terms of understanding the use case, we a lot of the time can now at least starting to get in here as expected. And that's when we look, we have to recap about concepts like function purity, argument adapter, Hoff, point free, which is define the relationship in a function. Transduction is a composition of reducers, of high order reducer, which is a matching mechanism to get the shape of one, to get the shape from one transformation and then make it compatible with the input of another function or another transformation. There is a lot of mathematical things happening here, and again, this goes beyond the scope of this, because what I want to focus my attention, right, is not only in the monad itself, all right, it's in fact is the next topic, which is handling the asynchronous map lazy and lazy arrays,
So far in this,
as well as observables, reactive programming, and RX, right? Because this is something that we're gonna use a lot. This is something we're gonna use a lot, right?
course, we've looked at a whole bunch of different perspectives on how we can perform operations on values in a functionally consistent way. So far in this course, we've looked at a whole bunch of different perspectives on how we can perform operations on values in a functionally consistent way.
Exactly.
But all of the values that we've been performing them on have been values that are
Exactly. So you got this async here, async, async here. In this case, is map lazy and lazy array. And lazy array, which is async. And I think this is an interesting segue here, because it's just as a way to develop an understanding here. And trust me, this is interesting. So far, we have looked at how can we define data and its operations in a functional programming way.
present at this form operations. So far in this course, we've looked at a whole bunch of different perspectives on how we can perform operations on values.
So far we have looked at how can we perform data operations, on values, okay, using functional programming
in a functionally consistent way.
Or in a functional consistent way. All right, good.
But all of the values that we've been performing them on have been values that are present at this exact moment. For example, we take the number 42 and we increment.
Exactly. So all of these values are performed in a synchronous fashion.
To the number 43, or we take a list of these numbers and we turn them into a list of strings. These are all things that are present immediately right now. The great part about functional programming is that all of the concepts that we have learned extend not just to the values that are present now, but also to the values that will be present eventually. So we want to look at a way, not the only way, but a way of adapting functional principles to asynchronous programming.
Okay, so we are going to see a way to adapt. We're going to see a way to adapt this.
So we want to look at a way, not the only way, but a way of adapting functional principles to asynchronous programming.
So we're going to see a way, exactly, a way. So we're going to see a way to adapt this principles, functional programming concepts to asynchronous programming.
I want to motivate that by first saying, here's a synchronous version of a .map operation. We have an array called A with the values 1, 2, and 3 in it, and we call A.map. We're going to get another array back, B, that has 2, 4, 6 in it. We can only get that array 246 because the numbers 1, 2, 3 were in the array at the time of the .map call. If I flipped this code around, if I said a.map on an empty array, and then after the .map call I added the numbers 1, 2, 3 in it, you're not going to expect those numbers to have ended up in B, are you? Because the numbers 1, 2, 3 were in the array at the time of the .map call. If I flipped this code around, if I said a.map on an empty array, and then after the .map call I added the numbers 1, 2, 3 in it, you're not going to expect those numbers to have ended up in B, are you? So that's what we mean by it is synchronous and it is eager. It's going to consume everything that it has available to it in that array, and it's going to do it right now. And if there's a value that comes later, if I later on line 8 said
that word, eager. Exactly. You're eager, impatient, anxious, eager execution. Okay.
A.push 4, that value's not going to show up in B, is it? Only the values that show up in B are the values that were in A at the time of the map. That's what we call synchronous and eager operations. But how could we do that same sort of functional concept of mapping and do it lazily over time? It seems like such a great concept. Is there any way to adapt it over time? I'm going to conceive of a hypothetical data structure. This isn't something that actually exists. But I want you to imagine if I had an operation called map lazy. Instead of map, which we know is map eager, what if I had a map lazy? It doesn't matter that this doesn't exist. This is just a construct for us to consider. Imagine a map lazy that creates some sort of a relationship between A and B, where at the moment on line 6, B is empty, but at some later time when I call a.push of 1, and A has the value 1, guess what is going to be in B? It's going to sort of retroactively run that map operation and show up in B. And then later, I could do a.push again, and the value will be not only originally
it's like
A,
listening to the some sort of that.
Can you see why a lazy map like that would be a nice, cool tool if we had? It would create this sort of asynchronous relationship between A and B.
That's what you have now, this particular
solve
pattern
a lot of our
here.
problems in terms of mapping, or in terms of annotating in our code flows of data that are not synchronous but asynchronous. Right? Imagine a composition that was like an asynchronous composition, where the thing was here, and then it was here, and then it was here, and then it was here. But there was time involved in between. So map lazy isn't a thing that exists, at least not in this particular formulation. Let's twist it around a little bit, and instead of thinking about a map lazy over regular arrays, maybe what we really need is a lazy array. What if I could construct a thing called a lazy array? We'll call it A. And then over time, I'm just going to set up an interval, and over time, once per second, I'm just going to push a random number into A. That would be an interesting data structure, because if I were then to set up a B, which was a mapping from A, over time, I would see the values showing up in B after they showed up in A. And the value that would show up in B was the mapped value from what it was when it showed up in A. There'd been instantaneous propagation from A over into B. Every time an A showed up, it would get mapped to a new value in B. And this b.forEach would sort of just be like an event handler that was just getting called every time a new value showed up. It invoked the for each, and in this case, console log. So it's sort of an event listener almost. Lazy array would be a pretty cool data structure, wouldn't it?
Lazy array will be
Can you see why lazy array, if it existed,
lazy array will be a very powerful data structure, man, because it can handle now this concurrency in time.
Would allow us to adapt all of the concepts that we know about functional programming. We know how to do them over arrays. Well, now we can do them over lazy arrays, which means we can do all of these functional things over time, including even things like transducing. You can even do monads over time.
Jesus.
Everybody follow what I'm saying? If we had this sort of a lazy array or a lazy map sort of function.
So
we don't
we
don't have lazy array, but what we do have is called observables. A lazy array, the way I have formulated it for you, is essentially, conceptually, an observable. If you haven't heard about observables, my favorite metaphor for them is it's kind of like a spreadsheet. If you take a value in a spreadsheet and put 3 in the cell A1, and then over here in cell B5, you say B5 is whatever is in A1 times 2. And so
okay. So if there are a data structure that allow us to store or record somehow.
So far, map lazy.
Okay.
Called do it lazily. 4. A value's not going to.
Because that's the whole premise here. So with map operations, exactly where they are, exactly with map operation where they are synchronous, when they are synchronous, like the following image, we can imagine a data structure, you know, structure that can now handle if our map in a lazy way, not eagerly. Okay, so anytime we add a value to such data structure, okay, somehow, okay, anytime we add this value to such data structure, somehow we can, okay, so anytime we add a value to such data structure, somehow yeah, so anytime we add a value, so anytime we add a value to such data structure, somehow this lazy map can evaluate and run the mapping function, right? So for example, like this. So for example, like this. So by the time we now add that data to one, we can also apply the transformations to that. And similar for this, and apply the transformation for that. So this wrapper, this data structure here,
push a random number into A. B after they showed up in A. And the value that would show up in B was the mapped value from what it was when it showed up in A. There'd be an instantaneous propagation from A over into B. Every time an A showed up, it would get mapped to a new value.
Mm-hmm. So anytime an update happens to A, it will automatically propagate those change to, is that anytime an update happens to A, it will automatically propagate those changes to B. With the transformation. Which is something that now, for example, Vue 3 is using Proxy as a way to detect that, right? Anytime as a way to detect this reactive data. So anytime you now actually detect a change for that, you use a proxy which will say, hey, this is now a wrapper, this is now a data structure around this value that is going to detect now when you perform some of this internal internal objects methods in JavaScript objects, right? So for example, get and set and has own and all that kind of thing. And a good example of this is when we go and say, hey, this is a proxy, right? So it means that in the end, right? So we can now also recreate this. Let me actually recreate this because this will be something interesting. We say, hey, yeah, this will be a proxy, okay? It has now the target, which is the object, as well as the handler. And this handler is now, let me actually make this. Did they make this in React? Jesus, everything is in me. React is so omnipotent, bro. Anyway, this is React developer here. Show me this in English. All right, there you go. The proxy objects enable you to create a proxy for another object, which is something that can now intersect that and redefine the fundamental operation of a project. Exactly. A proxy is someone that can act on behalf of something or can intercept, right? I just want to know is where are the object passes the second argument to the proxy construction contains the trap which defines the behavior of the proxy. However, this is now the handler, and the handler functions here is say, hey, I construct a trap from the new operator, define property, delete property, get something that I'm quite familiar is even with apply, man. Let me actually do this. Let's go to define now here a function, all right? A function that is going to increment that anytime you call that function, all right? So we can define here, say, hey, this will be our counter, but this counter let's gonna say is yeah, this is our counter here, and let me define this as a let. Okay, counter start with 0. Okay, we can also define as a function called here function add or increment, right? We're gonna get that counter, all right, and then well, no, and then let's say instead of doing this, you say, hey, increment, right? And we say, hey, I want you to increment is the counter. However, because by the time you run this function, okay, the counter value, it'll be depend of something outside of the function execution, because one is passed to the call stack. It evaluates this. You say, hey, let me now create a function execution context where you're going to have your thread of execution as well as your memory, okay, or your heap. And I'm going to evaluate whatever argument you pass to the counter parameter. In other words, whatever value argument you pass to the counter parameter, right? And I'm going to increment that, and I can say, hey, let's going to return that. However, here we're not keep tracking of anything. The one who's going to keep track of that is our outside context, right? So how can we do that? Instead of actually is now our global context to keep track that, we say, hey, let me is now define a counter here, okay, that is going to initialize as 0, and instead of returning the context, I would like to now return is the increment here, right? Where here I'm gonna say, hey, I want to access to the counter and then increment that. So what I'm doing here is now I'm storing this in this particular closure, right? This context, and then I'm going to call this now the counter, right? So what I'm gonna do here is now return is the increment. So by the time I create this counter function, and now I'm holding is the counter as 0, and return is this increment function. Behind the scene, what I'm telling to JavaScript is like, hey, please, I want you to hold a reference of this function here bounded with this data. Hey, this is your little backpack that I'm gonna pass to you. You're gonna store this in memory. So in memory, you will have now this reference, okay, pointing to this function. And anytime I call you that, you're gonna now is call that with your data attached to this, a closure. So let's get into this. You can say, hey, I want you to now here say this will be, I'm just gonna call this I'm gonna call this yeah, I'm gonna call this counter here, okay, and we're gonna define this as counter, okay, so that will be is the counter, right, and here we're gonna here we can say, or we can say start counter. This is start counter, right? We're not gonna receive any counter here. You can say start counter, okay? So this function we're gonna do is to create that, is gonna tell JavaScript to create that reference in memory, okay? By the time you evaluate all of this, and then now hold this reference here and this, hold the data reference and attach that to this function. So by the time we call that, we say, all right, we're gonna see increment that several times. Say counter, increment, similar to counter, increment, and so on and so forth, right? If you wanna console log this, similar for this. All right. Counter is not defined. What the French does? Oh, got it. It's because wait a single moment. Is because I need to actually is access to the context of this, right? Wait, what? Did I lose my mind? Oh, it's a counter does not exist. Which counter does not exist? Because I'm here assuming that I'm going to have access to that, because this was defined outer here, okay. And then you have here the start counter. Counter in line 14. Line 14, 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, 10. Come on. Type counter is undefined. Oh, really? But if I do this, it's a redeclaration of counts, that's right. But if I say counter, it say that this is undefined. Start counter. Okay. All right, that was weird. That was quite weird. If I say now counter 1, start counter, then I say counter 1, it says this is undefined. What is this? Oh, of course it's undefined. Because I am running this function here. And by the time I run that function, of course, there is nothing. And it is, in fact, is hold the reference, you know. It's like pass the reference here. Exactly. Counter increment is not a function. But counter now, it has this. Okay. Now we're passing is the reference. Okay. We're now executing the function. Counter dot increment. Oh, exactly, because we haven't. Yeah, absolutely, you're right. Absolutely, you're right. Absolutely, you're right. Yeah, you're right. Because we needed to say, hey, let me return an object, okay, that this object will have the increment attached to that function reference, right? Say increment to actually bind that reference here. And now it will say, all right, yes. But here we need to return is now this. It's a counter the increment exists, all right, but it doesn't return something. So let's go to actually is return something instead. You say, hey, I want you to now return something. So if we now reload this and then do that again, now we have our counter well defined. Okay, so is this one. However, what we can do here is that, hey, anytime we now call this function, all right, I want now to trigger how many times this function has been called. So it means that, hey, I want you to now, anytime you call now the start counter, not the increment, it's the start counter. I want you to keep track of this. How do we do that? We say, hey, let me now use the let me now use the handler here that we're going to pass to, which is count, which is the start counter, which is a function here. Okay, function object that I'm going to pass that to a new proxy, where the first argument it is the object. Okay, and the other is, because I don't want to call it, I want to pass is the reference to that. And the other is the handlers, right? Now you have any example here what I can go with? Exactly, the handler. So the handler here, right? You can say this one. This will be now the handler. All right, so by the time, instead of actually handling is the get, okay, we want us to now handle is the apply. Okay, what I handle is now the apply here. And the apply say, okay, this is now how it's going to handle that. This is a function that it receives the target, these arguments, and the argument list, and say calculate sum. In this case, I don't want to calculate any sum. Okay, it's just to now handles the I just wanted to show is that target call exactly, which is function call from the target. Okay, I don't want to actually output something or actually change that. The apply method can return any value representing the return value of the function call. Okay, and apply some transformations to this. And apply some transformations to this. This trap can intercept these operations. And here you say, because now this is what I'm going to apply and I want to return is the reflect.apply, which means that I don't want to do anything else for this. You know what I mean? I want you to now apply this. All right, this is the object that we want to have and the handler here. So it means that by the time we create now this counter proxy here, okay, with the star counter, and any time we define in our code is another new counter, counter 1, say star counter, right? That's right, counter 1 here. I don't think it actually works. If you define now this code but for the get, so the point of this, right, is that we are now able is by defining is this particular snippet of code in a closure, and then apply some property here by saying, hey, perplexity so hey, so based on the following code, fix it so we can detect when fix it so we can detect when a value or when a function or when star counter function is called. And add a console log with the another console log based on the object. Start counter function call and reflex.apply. Okay, target this exactly. It's just to pass down this. I don't want to do anything here. Exactly. So I don't want to do anything here. Okay, makes sense. Makes sense. So you can see is that start counter function call. Start counter function call. You know? But what you can do here is that any time that this particular function has been called, this method has been called, I want to apply something. So you can say is here and add this and say, hey, you know what? Start counter function call, and let's gonna pass this now, the target here. You know. And when you say the target, you say, hey, this function was called. This was the function that was called here. You know what I mean? With the arguments and the argument list and that kind of thing. However, you may wonder, is like, hey, how can I keep track of this function as being called, or who is actually registered that? Is now the proxy. Is now this data structure that allow us is to keep track, or that it provides this particular traps. So pretty much like in a game of this ball that you see a lot of in TikTok, when you have this ball game, or in this game when you have now when you are driving a car across multiple things in different platforms until you reach to the bottom. So it's pretty much all of these traps, right? So hey, if this happens, I want to trigger this. If this happens, I want to do this, and so on and so forth. That's interesting here. All of this is just to describe that we have now a data structure that allows to handle that case of the scenarios. And by the time that we now want to evaluate that in a lazy way, which is dealing is with the dealing is with a task that need to wait at some point in the future, because all of this is asynchronous. We can also say, hey, I want now to say something like this. I want to is now using this set timeout, right? Say, hey, after an X amount of time, all right, I want you to now console log this one, right? So after and 1 second, I want to call this, right? And this again. So, ridiculation, okay, no problem. Refresh. We got a new instance here of JavaScript. And then you got it, right? So, another thing that we can do here, I mean, is we need to wrap this as well. Because at the end of the day, we want is to actually is now handle this at some point in the future, right? We say, hey, I want now to after 3 seconds, right? is to, well, do this couple things here. Come on, do this couple set of instruction here. Say you do this. Hey, you do this. Okay, let's go into now is, well, create is this proxy, right? And that'll be all. Okay, then you got it. And after 3 seconds, this is interesting, bro. This is powerful as well. Why is that? Now we have now that a structure that is capable of, at some point in the future, allows us to trigger is a function, right? So this proxy is something powerful. As you can see here, it's a very powerful stuff, because now we can detect when a function was called, regardless, we can detect when a function was called, regardless how long it took for that. So it is time independent, man.
And this b.forEach would sort of just be like an event handler that was just getting called every time a new value showed up. It invoked the for each, and in this case, console logged it. So sort of an event listener almost. Lazy array would be a pretty cool data structure, wouldn't it?
We should create this scope.
And you see why lazy array, if it existed, would allow us to adapt all of the concepts that we know about functional programming. We know how to do them over arrays. Well, now we can do them over lazy arrays, which means we can do all of these functional things over time, including even things like transducing. You can even do monads over time. Everybody follow what I'm saying? If we had this sort of a lazy array or a lazy map sort of function. Well, we don't have map lazy and we don't have lazy array, but what we do have is called observables. A lazy array, the way I have formulated it for you, is essentially, conceptually, an observable. If you haven't heard about observables, my favorite metaphor for them is it's kind of like a spreadsheet. If you take a value in a spreadsheet, like you put 3 in the cell A1, and then over here in cell B5, you say B5 is whatever's in A1 times 2. And so now B5 is showing you the value 6, right? Because you have 3 here and 6 here. What happens if you change that to 4? If you change cell A1 to 4, what's going to show up in cell B5? Instantaneously, it's going to show 8, right? There is a relationship between the cell B5 and A1, and that relationship is a mapping that doubles the value. It is that equation that is mapping the value. And that is essentially the same thing as what we were just showing. It's the idea of an observable, which is an asynchronous flow of data. If I put the number 4 here, it flows through a mapping operation over to this other cell. And if I were to take another cell like C10 and have it be whatever's in B5 plus 1, what is C5 going to be showing? It's going to be showing 9 now. What happens if I change this value to 5 again? Well, now we're going to have 5, 10, and 11. You see how the data flowed asynchronously through that stream? That's my favorite metaphor for describing the concept of an observable.
I think that we can get the target this argument list.
Rx is a library that has been ported to
target.
It was originally written for .NET, but it's been ported to JavaScript. It's been ported to PHP and Python and Scala and like a dozen other languages. And it's a library for doing observables. Rx stands for reactive extensions, reactive programming. That's this general header that observables.
Wait a single moment.
So
this is handler.
Glimpse at observables. This course is not actually in scope to teach you all about observables. That's a whole other course here on Funding Masters, actually. But I just want to show you how we can do the functional concept with an observable. Okay? So I'm going to say rx.subject, that makes me an observable. And then I can call .next on a subject, which is what
the target callable object.
Pushing a thing into it. And then somewhere else,
so if that is an object,
get a new observable out by calling a.map. And that
and the property of these objects,
and it will be notified every time a new value shows up in the B observable. This code is almost identical to the lazy array that I just showed you. We've swapped in rx.subject for lazy array, and we've swapped in a .subscribe for a .forEach, but conceptually it's the same thing.
So object here. data assign, define properties. Get our property names, the property symbols. Is extensible, is frozen, is seals, keys. All right, okay. So we'll leave this example here. Say started counter. And now we can say, hey, since this is now defined in another different context, so if you clear here the console here, well, okay. Exactly, and then after 3 and 3 seconds, bam, start counter function call. This is something interesting because again, this is allowing you to keep track. This data structure provides you now an ability to keep track is when those states change, right? Which is the core fundamental of View 3 behind the scenes. Why do we care about in our functional programming, in our asynchronous programming? Because we can apply all of this particularly functional data operations that we can apply this data operations on values in a functional way, or in a functional reasoning, because at the end of the day is that in a functional consistent way. In a functional consistent way. So if we can apply this to synchronous data, how can we apply now that to concurrent data? Data that we have to wait for some point at some future, right? So let's get into this.
Can you see why lazy array, if it existed, would allow us to adapt all of the concepts that we know about functional programming? We know how to do them over arrays. Well, now we can do them over lazy arrays, which means we can do all of these functional things over time, including even things like transducing. You can even do monads over time. Everybody follow what I'm saying? If we had this sort of a lazy array or a lazy map sort of function. Well, we don't have map lazy and we don't have lazy array, but what we do have is called observables. A lazy array, the way I have formulated it for you, is essentially conceptually an observable. If you haven't heard about observables, my favorite metaphor for them is it's kind of like a spreadsheet. If you take a value in a spreadsheet, like you put 3 in the cell A1, and then over here in cell B5, you say B5 is whatever's in A1 times 2. And so now B5 is showing you the value 6, right? Because you have 3 here and 6 here. What happens if you change that to 4? If you change cell A1 to 4, what's going to show up in cell B5? Instantaneously, it's going to show 8, right? There is a relationship between the cell B5 and A1, and that relationship is a mapping that doubles the value. It is that equation that is mapping the value. And that is essentially the same thing as what we were just showing. It's the idea of an observable, which is an asynchronous flow of data. If I put the number 4 here, it flows through a mapping operation over to this other cell. And if I were to take another cell like C10 and have it be whatever's in B5 plus 1, what is C5 going to be showing? It's going to be showing 9 now. What happens if I change this value to 5 again? Well, now we're going to have 5, 10, and 11. You see how the data flowed asynchronously through that stream? That's my favorite metaphor for describing the concept of an observable. Rx is a library that has been ported to a bunch of different languages, originally written for .NET, but has been ported to JavaScript.
RX, interesting.
Ported to PHP and Python and Scala and like a dozen other languages. And it's a library for doing observables. Rx stands for reactive extensions, reactive programming. That's this general header that observables.
Okay.
And like a dozen other languages.
So now that you have is the reactive programming with RX.
And it's a library for doing observables. .NET, but it's been ported to JavaScript. It's been ported to PHP and Python and Scala.
Okay, JavaScript, PHP, Scala, Python. But again, it's to handle this particular pattern here.
Like a dozen other languages. And it's a library for doing observables. Rx stands for reactive extensions, reactive programming. That's this.
It's a library for handling this observable reactive programming.
General header that observables follow. So I'm only showing you the briefest glimpse at observables. This course is not actually in scope to teach you all about observables. That's a whole other course here on Front-End Masters, actually. But I just want to show.
Handling HTTP requests with observables. And JSON-P as an observable.
Today we're going to be doing the advanced version. I assume most of you guys have taken my last class by now. And if you did, you remember that we did a lot of basic exercises to sort of strengthen the basic skills.
Event-driven system. Oh my God, he is the Netflix representative of the JavaScript standard, committed and actively working to evolve JavaScript. God damn it, bro. Formal engineering at Facebook, Meta, Netflix, and Microsoft. God damn it, bro. Okay. Okay. Okay.
You how we can do the functional concept with an observable. Okay? So I'm going to say rx.subject, that makes me an observable. And then I can call .next on a subject, which is what I'm doing over time. I'm saying a.next and pushing a thing into it. And then
pretty much like an iterator here.
Or else I can get a new observable out by calling a.map. And that new observable B I can subscribe to, and it will be notified every time a new value.
So here you are, exactly. But this is now, following is the observer design pattern. The observer design pattern. A time-oriented data structure that allows for achieving functional concepts. A time-oriented data structure. This kind of people actually handle it with a lot of structure. These people actually handle, I don't know what they're smoking, bro. Mathematics. That's what they're smoking, bro. Mathematics. They're taking a book. No, they're taking they're taking this notebook, right? They roll up very hard, and then, well, get this functional approach. Holy moly, bro. Okay, so you're defining, look at this. You are defining here is now a subject, which is this data structure, a time-oriented data structure, okay? That it say, hey, at some point in the future, I'm going to now call this to add some random number here. At every second, I'm going to now run this X amount of time, X amount of data to these collections or to this sequence, right? And then I can not only is subscribe a map.function, or in this case is to say, hey, I want to now get a map here, so I want to have a reference of this map here, and pass this double, okay? So by the time now I subscribe to that B, I'm gonna pass now a value here and gonna console log that.
Shows up in the B observable. This code is almost identical to the lazy array that I just showed you. We've swapped in rx.subject for lazy array, and we've swapped in a .subscribe for a .forEach, but conceptually it's the same thing. We have one stream of data that is getting values pushed into it, .nexting into it over time.
Exactly, we got now a stream of values because this sequence has become now a continuous and infinite until at least what memory allows us to. But it has become this sequence of these streams of values that we can add data to this, right? And then apply some transformation whenever we now detect a change to that.
And we have another stream of values, and those two streams are observables. And every time we call an operator on an observable, like .map or .filter or .reduce or any of literally 200 different operators that this API provides, what do you get out on the other side? You get another observable.
Another observable.
Just like with .map, you get another array or a monad.
Exactly, just like you get, exactly. Just like the map getting a data structure, you also is gonna get is this data structure with this. Okay, you always gonna get this data structure with this transformation you are gonna apply. RxJS, Jesus. So they now provide is Jesus. This is not the reference here. Async deprecated API list. Okay, so count. and concat and every, you're gonna get an observable of this. Exactly. At some point you're gonna apply this. And it says interest because this is now how they are applying this functional stable operator. And anytime you apply any of this, you say map. Anytime you apply now this, you're gonna get is now an observable. And this one. You're gonna get an observable is with this transformation as they come here. So you say, hey, from this here, from events, pointer events, hey, I want you to now is get the position, all right, because I'm getting is now I'm getting is now in the streams of data and reactive observer lazy map this reactive objects that is time orientated. Damn, so and then anytime this clicks streams of data receive any updates, right? Now you're going to say, all right, I want you to now apply this operation. Okay, and that is give me is the position of that. Holy shit. Okay, Jesus, French toast guy, bro. Jesus, French toast guy. And the return is an operator function, and an operator function is now an observable. It extends for unity. Observable. It's a streams of data. It's a streams of data. Now we are working with another data structure. Jesus, unlike arrays, maps, hash, arrays, linked lists, binary linked lists, binary search tree, and then with some of these techniques in computer science, like sliding windows or two-pointer. Okay. Now it is time to look at this. Holy sh! This another data structure, pretty much like monads is another data structure. It's a functional data structure. Now we have is a data structure that represents this time-orientated things. Where now with functional programming, this monad is represent now is a state change. This is something interesting that all of this way of organizing stuff represents. So you have now an array, a sequence. You have now hash, like a table, a key value pair, right? With these two things. You have now linked list, a collection of values dynamically, or this binary tree, which is a way of how you can organize that with two childs components, right? Similar like a tree with two branch only, right? And also when it comes to now is represent state change over time, all right? A good way of understand that state change is by taking a snapshot of you early in the morning for the next 10 years. You want to take now a snapshot of that, or if you want to keep track of your health, all right, you want to now see your progress, okay, at the mirror, day 1, day 2, day 3, day 4, you know, until you get old. But that's the idea of this, is that we have now a data structure that represents those state change. And another is a data structure that that represent now streams of data, which is data that comes in like a flow, like a river. So for example, when someone is talking to you, you're actively listening to what is mentioned, all of these particular words that you get, or when you're consuming content, it's like all of this image that you are perceiving when you watch Game of Thrones, right? So now you have a way to organize that and then apply some transformation to this data. That's the abstraction here. That's the abstraction. That's where the value comes here. The value not only came for the abstraction, the value came from what are the things that you can do with those abstractions to apply in to get the outcomes that you want in your life. Oh my God. He's the architect of Netflix UI data platform and specialized in building reactive event-driven systems. Oh my God. James. Oh, grip. Jesus. God damn. Oh, grab, man. I get it, bro. Holy moly, bro. Oh, crap. God damn it, bro. Jesus. Jesus. Damn, son. Damn, son. Damn, son. Holy French toast, bro. 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 Jesus, French, okay. Holy French toast, bro. Holy French toast, bro. Okay. Holy. Anyway.
.map, you get another monad. When you do observable.map, you get another observable. So it's these streams of data that are declaratively flowing from one to the other, and in between them are Rx operators, like .map, .filter, or distinct until changed, or any of the 200 other operators that exist. So all of the things that we've learned about
Names.
functional programming, we first learned to lift those things to a data structure. That's what our previous unit of discussion was all about. How do we lift things to a data structure? Well, now let's lift things to a time-oriented data structure called an observable. Yes?
Would you characterize this like kind of a functional version of pub/sub kind of architecture?
It's a functional version of event-oriented programming. I'm not sure I would necessarily go so far as to say pub/sub because there's more semantics involved with pub/sub.
PubSub is a form of asynchronous service-to-service communication.
But it's definitely, I mean, the terms observable and stream and event stream are almost used interchangeably. They technically mean slightly different things, but there's like 98% overlap. If you say an observable or you say an event stream, if you do it, if you can think in event-oriented programming, that's basically what reactive programming is doing. It's reacting to an event, observing an event. Observables are not the only way for you to adapt functional principles over time, but I think they're one of the most compelling, certainly one of the most natural extensions of what we've already learned, because they have method names like .map and .filter, and they use the ideas that we've already learned about, and they extend them over time. So I think it's a good place to start when trying to adapt your functional programming to the time component of your application. Let's do an exercise on extending our functional principles, our functional programming principles, over asynchronous, over time, using what we just learned about observables. In this exercise, you're going to be wiring up an observable and making it do essentially a countdown timer in the console. I think it's probably better.
Okay, so that'll be all for this video. Take care. Bye-bye.